assembled and integrated into SLS. The core stage's 5 sections will need a combination of more than 750 sensors, 45 miles of cabling, and 100,000 fasteners. All that work is being done as we speak. Let's take a closer look. At the base of the core stage sits the engine section, home to the 4 RS-25 engines, the thrust structure they push against, as well as more than 18 miles of cables. Because of this section's complexity and the extreme temperatures and vibrations it will experience, nearly 500 sensors are being installed in the engine section to monitor conditions. The core stage contains 2 separate fuel sources, the liquid hydrogen tank and the liquid oxygen tank. Together, they hold a combination of 733,000 gallons of propellant. This fuel is kept so cold that it will actually shrink the tanks up to 6 inches in length and more than 1 inch in diameter before they expand again as the fuel empties. That means that anything attached to the tanks must be secured with a variety of flexible or accordion-like or telescoping connectors. The intertank is designed to connect the 2 fuel tanks. It isn't being welded together like the rest of SLS. The intertank is being put together by 14,500 custom bolts, fasteners, and fittings. SLS is in its forward skirt section. The 45 miles of cables controlling the SLS eventually lead to the forward skirt section, where 3 flight computers monitor more than 1,100 sensors to ensure a successful flight. Power for the computers and other core stage electronics is provided by 4 lithium-ion batteries. Each is about the size of an average car battery and provides about 1.8 kilowatts of power for the rocket's 10-minute mission. NASA engineers are working hard as we speak to make sure that every part of the core stage is outfitted and tested. But that's just the beginning. Once the individual sections are complete, the whole thing needs to be assembled. But we'll save that for another time. Thanks for watching.
It has been called the world's greatest piggyback ride, a space shuttle atop a Boeing 747 jet aircraft. But this is no ordinary 747. This is the Shuttle Carrier Aircraft, the SCA. This specially modified jumbo jet was not only a taxi service for the shuttle, but also helped in the development of the shuttle itself. In 30 years of flying, the majestic image of a spacecraft joined to the SCA became a symbol of American invention and ingenuity. You searched the sky. You heard the roar of the engines getting closer. Then someone would shout, "There it is, the SCA." In the 30-year history of the space shuttle, if you were one of millions of people who saw the SCA fly over your town, you understood the excitement it could generate.
So it was always a pleasure to have the locals come out and have the kids be able to look up and see a shuttle sitting on top of an airplane. That's certainly a huge memory of mine. When I was a teenager, when I lived in Huntsville, Alabama, where I was raised, and at the time I was at Von Braun Civic Center in Huntsville and looking up and seeing this airplane, and who would have thought that I would have ever flown this airplane? I mean, how ironic that I would end up being a guy who flew the airplane and being lucky enough to be the last guy to fly this vehicle for a 30-year shuttle program.
The unique image of 2 sleek vehicles attached in a seemingly impossible configuration evokes feelings of progress, elegance, and achievement. To understand how the shuttle carrier aircraft came to be, you must understand the shuttle itself. It was America's first reusable spacecraft, At the end of a space mission, the shuttle would re-enter Earth's atmosphere. Then it would glide down to a runway at the Kennedy Space Center in Florida. There, engineers would get to work refitting the spacecraft for another mission. But NASA had other landing sites, such as Edwards Air Force Base in California. If the shuttle landed here, it would need a way back to its launch site in Florida. For flying the skies on Earth, NASA engineers first thought that perhaps the shuttle could have its own jet engines. But these proved to be too heavy, too complex, and too costly to develop. NASA would have to find another way to transport the shuttle. Enter John Kiker, an engineer at the NASA Johnson Space Center in Houston, Texas.
I made a little sketch of this and put it on my desk, and then after several weeks I called up Owen one day and told him not to laugh, but I wanted to show him something.
Using model airplanes, Kiker and his team proved the concept of transporting the shuttle on the back of a 747 jumbo jet. In addition, the tests showed the shuttle could be air-launched off the back of the plane. The idea was accepted, and the shuttle carrier aircraft was born. The SCA first flew the shuttle on what was called the approach and landing tests. The shuttle Enterprise was lifted on the back of the SCA to an altitude of about 27,000 feet and air-launched. The aerodynamic tests were crucial in proving the shuttle's ability to glide down to a landing and helped engineers refine the shuttle design. Just as significant, the imagery of the SCA and shuttle in action was the public's first glimpse of an amazing new era of spaceflight that was just on the horizon. The shuttle became a renowned and iconic space vehicle. The SCA allowed those of us on the Earth to share that excitement when it served its role as a shuttle taxi. Mission by mission, SCA crews eagerly listened for word if the shuttle would have to land somewhere other than Florida.
We start getting excited when we hear that the weather is bad in Florida. Those few of us that fly this airplane like bad weather in Florida. So we get a chance to do our job. So as soon as we know that the shuttle is en route to California, that's when we start getting involved with the shuttle ferry team. So basically the shuttles are brought into the demate facility, and they're hoisted up, and the shuttle carrier aircraft, the 747, is moved under the shuttle, and then the attachments are made.
The shuttle and its cargo can weigh anywhere from 160,000 to 220,000 pounds. To lift and fly with that much weight on its back, the SCA had some special modifications that made it unlike any other jetliner. Most noticeable were vertical fins mounted on the tail. The shuttle caused air turbulence, and the fins brought back stability to the flight. Other than the fins, it might appear this was an ordinary jumbo jet. But as SCA flight engineer Henry Taylor can tell you, there were some very important differences between a regular 747 and a shuttle carrier aircraft.
We're here inside the main cabin of the shuttle carrier aircraft. As you can see, there's no insulation, no paneling. All the lavatories and galleys have been removed to save weight. Above me is one of the two bulkheads, this one and this one, that are used to provide support for the orbiter attachment.
Flight. The highly skilled crew monitored the systems carefully and experienced a different type of ride.
From a pilot standpoint, there's a long wait. When the power's pushed up, you don't really realize the time that you're going to be on the runway before rotating the airplane into the air. So there's a big wait, and that's the big thing that was impressed upon me, I think, during my first shuttle fair.
As the shuttle program ended, the SCA had one final mission: deliver the shuttles Enterprise, Discovery, and Endeavour to their respective museums. Across the United States, for one last time, people got to see the unique vision of spacecraft and aircraft joined in flight. And with that, the SCA with the shuttle was not seen in the sky again. But it will always remind us of a bold age of determination and invention.
When the orbiter is on top of the SCA, it just creates so much interest because it's such a unique site that people come out by the thousands to see us wherever we stop, to come see this very unique combination. People appreciate and people respond to things like that. The American ingenuity and American pride.
A mighty powerful spacewalk outside the space station, a look at the space station's next crew, and updates on our Artemis program. A few of the stories to tell you about this week at NASA. On July 1st, our Chris Cassidy and Bob Behnken were outside the International Space Station for their second spacewalk in less than a week.
You have control of the battery. I do. I'm in a good spot.
The pair continued upgrading power systems on the station, replacing aging nickel-hydrogen batteries with new lithium-ion batteries. The battery upgrades are expected to continue on future spacewalks, with target dates and times to be announced once mission planners assess the scope of the remaining work to be done.
You really feel it when you arrive at the space station and see this hardware and see these modules put together and flying in space. It's one of the most incredible engineering achievements I think that humanity has done.
NASA astronaut Kate Rubins discussed her upcoming second mission to the space station during a July 1st press conference at our Johnson Space Center in Houston. She was joined by Sergei Ryzhikov and Sergei Kutsverchkov of the Russian space agency Roscosmos. The trio is targeted to launch to the station October 14th from the Baikonur Cosmodrome in Kazakhstan. NASA is working with contractor Northrop Grumman rocket boosters to support as many as 6 additional flights for a total of up to 9. Northrop Grumman is the current lead contractor for the boosters that will launch the first 3 Artemis missions, including the one that will land the first woman and next man on the moon in 2024. We've wrapped up testing on the Orion Structural Test Article, a twin copy of the spacecraft needed to verify Orion is ready for Artemis 1. The testing, which began in early 2017, was designed to thoroughly evaluate Orion's ability to withstand the stresses of launch, climb to orbit, harsh conditions of deep space transit, and return to Earth. Engineers completed the Space Launch System rocket's structural testing campaign for Artemis missions by applying millions of pounds of force to the rocket's liquid oxygen structural test tank. The tank failed within the parameters expected, proving flight readiness and providing critical data. The SLS rocket, Orion spacecraft, Gateway, and Human Landing System are part of NASA's backbone for Artemis, our next step in human space exploration. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
What is a CubeSat? CubeSats are very small spacecraft that orbit Earth. As you might guess, a CubeSat is shaped like a cube, about 4 inches wide, long, and deep. That's called 1 unit, or 1U, small around 3 pounds. And like building blocks, units can be combined to make bigger CubeSats by stacking them into 2, 3, or even 6 units.
Once in space, CubeSats can open up all kinds of tools: solar panels for power, communications antennas, telescopes, and more. CubeSats are great because they let schools, universities, and other teams launch their very own missions, and who knows what they'll discover. CubeSats are also made from standard, low-cost parts that are easy to get and tested for launch safety. Some NASA launches carry spacecraft that don't take up all of the space on their rockets, which leaves plenty of room for tiny CubeSats. Build a CubeSat, catch a rocket ride, and you become a space explorer.
Hi, I'm Alex Matrix, a software developer at Marshall Space Flight Center in Huntsville, Alabama. This is Rocket Science in 60 seconds. The avionics are the brains behind the Space Launch System rocket. They are the computers and electrical systems that fly, track, guide, and steer the vehicle throughout its launch. The avionics make the rocket fly by guiding and directing all of its thrust power. The rocket launches with more than 8 million pounds of thrust from its engines and boosters, and with the help of its brains. We present the flight computers with different types of faults and still make sure the vehicle flies safely. You can't run that many tests on actual hardware, so these scenarios are very valuable. Using the software that I help write, I get to watch the SLS rocket launch nearly every day. The only thing that could rival it is the actual Artemis mission to the moon.
This is a lab. Measuring instrumentation, probes, sensors, gas and liquid chemicals, computers. Yeah, this is a lab, but maybe not the lab you would expect.